Hey, my name is Milan, and in this video I'll show you how you can use stored procedures and functions with EF Core. These are pretty common when working with legacy databases, and integrating them is pretty easy with modern EF Core, so let me show you how. I'll use an existing database for this demo, and it's going to be Postgres with a couple of tables inside. And we're going to define some functions and store procedures that are going to query against these tables. They're all present in the ticketing schema. And let's start with a simple function that's going to allow us to check how many tickets we have available for a given ticket type. So I'm going to drop in the SQL for defining this function, and I'm going to call this function ticketsLeft. The parameter is the ticket type ID, and it's just a simple query on the ticket types table to check what is the available quantity. So if I execute this, it's going to define this function, and then in order to call it, I need to say select, invoke the function, and pass in the ticket type ID. So if I go into the ticket types table and look at my data, I'll choose the VIP pass, for example, and grab the ID. I'll specify it here. And now, if we invoke this function, we're going to see that we have 95 tickets left. So calling this from SQL is pretty simple, but how can we call it from our .NET code using EF Core? If you want to follow along with this video, the source code can be found right below in the pinned comment, and you can download it for free. And once you do, you can grab the SQL for seeding the entire database, including some dummy data that we can use for testing purposes. And there's a separate SQL file that contains the function definitions that I'm going to use in this demo. So let's first see how we can query our function for returning the available quantity for the ticket type. The route is going to be ticket types. Then I'll specify the ticket type ID as a route parameter, and then let's say available quantity. For the request delegate, we're going to need a couple of things. So first we need to grab the route parameter, which is the ticket type ID, and then we need our database context. I already have this defined, and it's configured to access all of my tables, so we're not going to spend time on this. And let's call this the database context. So now I can define my request body, and here I want to process this request by calling the function that's already defined in the database. So let's define a variable that's going to hold our result, and we can say database context database, and then the method you want to call is SQL query. So here you can specify your generic parameter. I want to map this to an integer, for example, and then I can define my actual SQL. And if you recall, this is just calling the function that we defined earlier. So let's say select ticketing, tickets left. We somehow need to specify the ticket type ID, and we can pass it in by using an interpolated string. Now, in order to map this to a scalar value with EF Core, we need to return this column as value. So then I can say first async, and we should be able to execute this and return our result from this endpoint. Now, a couple of remarks here. I know you're probably already screaming at the screen that this introduces a SQL injection attack. Well, it's not actually the case. Let me show you why. So let me define my SQL as a string. Now I'm going to grab what we have here, and I'll have to just write it like this because I want to use quotes in my actual query. And if I try to pass this directly to the SQL query method, you'll see that we are running into a compile exception because we can't pass a string to the SQL query method. And this is because the actual parameter that we have here is a type, and it's called a formattable string. So what's the catch? The formattable string is going to detect any interpolated values that you defined, and it's just going to convert them into SQL parameters. So the query that we have here is going to be parameterized, and you won't really have problems with SQL injection attacks. Now let's try to run this and see if we can get a result back. I'll send a query to fetch the available quantity for our ticket type, and we hit our breakpoint here. And if I try to execute this, you can see that we do indeed get the result back, and it's 95, the same value that you saw inside of the beaver. So if I press continue, we should get back this value in Postman, and we're able to call our SQL function in a very simple fashion using EF Core support for raw SQL queries. This is the approach I would recommend if you ever need to interact with a function or a stored procedure or even a view inside of your database. There's another option called SQL Query Raw, which does allow you to pass in an actual string, but it shouldn't be interpolated, and you have an option to pass in the parameters afterward. There's a remark in this method that you don't really get protection against SQL injection attacks, and it's recommended that you use the SQL query method. So that's what we're going to use for our demo. Now let me show you a couple more complex examples. So this is just mapping a simple scalar value as an integer and returning it. Now let me show you some more complex examples. I have a function here that's going to return the order summary for a given customer ID. So I'm going to replace the SQL here with our new function. I'll execute this, and now we have our function defined. How you use it is you say select star from ticketing, then you specify the function name, it's customer order summary, and all we need is a customer ID. So I'll go to the customers table, find the one customer that I have, let's say Alice, and I'll use this ID in my query. And once we execute this, we get back a table. It contains the summary for all the orders for this customer. Now, this is a bit different than returning a simple scalar value, and we would want to map this to some DTO inside of our code. Let me show you how we can do this. I'm going to define another endpoint here. Let's say map get. Let's call this customers, customer ID, and then let's say order summary. Our request delegate is going to contain the customer ID and the event management context. We'll call this the DB context. And then what we're interested in is how do we call our new function. So it's going to be quite similar to what we had before. Let me see if I can autocomplete this to save us some time. I think I can, but we're going to change a couple of things. First, I'm going to rename this variable to be orders. And why is that? It's because I want to return an order summary DTO. This is a type that I already defined, and it just contains the same properties as the columns that I want to return from my database. So now I can use this type when I pass in the SQL query, which I'm going to update to this. The same thing you saw me do in dbeaver. We're just calling this function, passing along the customer ID. Again, noting that this is a formattable string and this will be converted to a parameter. And what's important here, at least from my testing with the Postgres provider for EF Core, is that I have to project the columns into Pascal case names so that they are mapped correctly to my DTO. Then I want to say to list async to project this to a collection of orders, and then this is what I'll return from my database. So let's test this out. I've got my endpoint prepared here, so let's send this request, and we land on the respective breakpoint, and when I execute this, we do indeed get back one record that contains our order summary DTO with the order ID, the item count, the total price, and when this order was created. So if I press continue, we'll get back this result in Postman. So now we also know how to call a SQL function that returns a table result and how to project this to a DTO. Now let's look at a more complex example. So far, we've only been working with functions that return some data, but it's pretty common that you're going to execute some sort of stored procedure that's going to run some business logic on the database and perform an update. So what I have here is a function that's going to adjust the available quantity for a ticket type based on some delta that we specified as a parameter. The difference between functions and procedures in Postgres is that procedures are allowed to work with transaction commands, whereas functions are not, and procedures typically aren't used for returning data. You can't directly return something. Instead, you'd have to use output parameters. This is a bit complicated, but nonetheless, let me also show you what it looks like to work with stored procedures. I'll drop in the SQL for defining our procedure. You can see it's created. And then in order to call it, we have to say call, specify the procedure name, specify the ticket type ID, and then the quantity for how much we want to adjust. So let me see where I have some leeway. I'll pick this one where the available quantity is 480. I'll specify the ticket type ID here. And then if we execute this, let's say twice, you can see it execute successfully. And I refresh this table. This is now going to say 490. So our stored procedure works. Now let's see how we can call it from our code. In order to save us some time, I'm just going to drop in the code because it's much of the same. But what you want to do with procedures is use a slightly different method because it doesn't return a result, and that's calling ExecuteSqlAsync. This is quite similar to calling execute non-query with Dapper. So we're just saying call, specifying the function name, specifying the stored procedure name, and then passing along the ticket type ID and the quantity as the two parameters. Both of these are going to be converted into proper parameters because this is a formattable string. And then we can just return the result, which is by default going to be -1 because we don't get the number of updated rows when we call the procedure. So let's test this out. I'll place a breakpoint here and I'll send this post request that I prepared to update the ticket type quantity. And then inside of our API endpoint, we're going to call this. You can see it completes. We get back -1 and I'll press continue and we get back just this value inside of Postman. However, if I use this to check the available quantity for my ticket type, you can see that we get back 495. Now let's execute this one more time. It completes, and this time when I query this, we get back 500 because we've increased the available quantity using our stored procedure. And let me show you one more example that's super interesting. And as I said, you can grab the source code for this video completely for free from the pinned comment that's going to be right below. And what I have here is a really big SQL function that's going to map my result or project the result of my query into a JSON object. So Postgres has very extensive support for working with JSON, and I'm using that to map a complete order DTO from Postgres into a JSON object that I'm going to return from my database. So this is really taking it to the extremes, but nonetheless, let's take a look at this. I'm going to drop this function into my database. I'll paste the code for this function here. Let's execute this. We have this function defined, and how we call it is we just say select get order DTO, and we specify the order ID. Now, if I take a look at the orders table, I believe I have only one order, so I'm going to specify that order's ID. And if we execute this, we get back some very convoluted and long SQL response. So how do we map this to an object inside of .NET? Again, in the spirit of saving us some time, I'm just going to drop in the implementation because it's much of the same when it comes to invoking this function. But what changes is we can't directly map our JSON object that Postgres returns into an object with EF Core. So we have to resort to this approach where we project this to a scalar value, a string, and because this is a JSON string, we're going to deserialize this into the order DTO. So let's check if this works. I'll run my application, and if I send a request from Postman to fetch this order, you can see that we get back a response. It's a complete order DTO that we mapped directly from JSON. And let's take a quick look at the telemetry. If I jump into the traces, you can see the request that I sent here to my database, and the SQL is just projecting the value that we get back from our function. Now, one thing to note is that EF Core is somewhat verbose when it comes to adding some additional SQL around the query that you wrote, but most of this is going to get optimized away, and you're just going to end up executing what you have here. Now, notice that our value, the order ID, is represented with a parameter. So you can see that the parameterization of these queries works as expected because, as I said for a number of times in this video, we are using a formattable string, and this isn't really susceptible to SQL injection. If you want to learn more about using EF Core, I highly recommend checking out this video next that deals with the database first approach with EF Core. You can also grab the source code for this video completely for free from the pinned comment right below. Thanks a lot for watching, and until next time, stay awesome.